Okay, so this is Algebra 1, operations with real numbers. At the top of your notes, you should put the date. The date is 8/22/24, right? August 22nd, 2024. Why do you do that? So you know what date we did the homework, correct? Organization. So what are we going to do to classify and order real numbers? Use set notation, find subsets of real numbers. Those are the two objectives we're going to do today. They're pretty simple. It's not bad. Okay, translating words. What does sum mean? You may know what that means in mathematics?
The total.
Add. Very good. It means to add. Secondly, what's difference mean? Divide. Difference. Subtract. Correct? Means to subtract. Subtraction. This is addition. Are you guys able to see this in the back or not? I need to write bigger. You're working out? Okay. Product. What does product mean? Multiply or multiplication. Quotient. What does it mean? Division or divide. So it's classification of numbers. Natural numbers are the first numbers you learned. I don't know, probably kindergarten, how to count, correct? So what are the natural numbers? 1, 2, 3, 4, 5, 6. And when you see that, ... what does that mean? And it just keeps going, doesn't it? Correct? Whole numbers are when you started subtracting about second grade and zero is introduced. Remember what's 5 minus 5? 0. So then whole numbers are the natural numbers plus what number? 0. Okay? Integer numbers. Integer numbers are all the whole numbers and their opposites. So what's the opposite of positive 1? Negative 1. 0 does not have an opposite. So you can do it like this. I go ... -3, -2, -1, 0, 1, 2, 3, ... Okay? So it goes in both directions, doesn't it? Okay, a rational number. All these here make up a rational number because all of those can be written as a rational number is any number that can be written as a fraction. Any number that can be written as A divided by B. A and B have to be integers. Integers. That means no decimals, no fractions, okay? Also decimals that terminate. Does anybody know what terminate means? When you terminate a relationship, what does that mean? It stops. So like 1/2. What's the decimal for 1/2? 0.5. It keeps going, doesn't it? Right? It's also, or ending as a rational number, it repeats or keeps going or repeats. Does anybody know the number that repeats? Yep. Pi keeps going, but it doesn't repeat. We'll talk about pi here in a second, but I like that. What's 1/3? Okay.
0.333.
Exactly. Watch this. Everybody get your calculator out. Okay, we'll teach you how to use this thing. To turn it on, hit the bottom left-hand button, okay? Right? Everybody have it turned on? Hit the bottom left button right here. Yep. Just it doesn't matter. Just go hit on it. Just get out of it. Does it need a new battery? Okay, if it doesn't work, you can do it later. You'll bring it up here in a little bit, and I'll put batteries in it for you, okay? But just watch for now, and then you can go back later and watch the video, okay? And I'll put batteries in that here in a second. Sorry about that. So watch. Let's take 1/3. Take 1, all right, and then hit divided by 3. And what do you notice? What's it do? It just keeps going, correct? That's a rational number. Why is it a rational number? Because 1 divided by 3. Agreed? Now, somebody said pi. Agreed? Pi is not a rational number. So hit the second key. Hit the second key, the blue key. And let's see if we can find pi. I don't use pi much. I do in geometry. I love to eat pi though. So let's see if we can find pi. Go to math, hit math, and let's see if we can find pi. Arrow over to number.
Press the second so I have the clear button.
You think you found it already? Does everybody see pi on in the blue keys?
Yeah.
Which is it? Oh, it's division. Everybody's, yeah. So everybody don't get out of that. Hit second quit. And you guys see, hit the blue key, and then you see right here, there's pi, and then hit equals. And what do you notice with pi? Do any of those numbers repeat? No, it'll keep going forever and ever and ever and never stop. That's called an irrational number. So a rational number is a terminating decimal like 0.5, correct? 1 divided by 2 is 0.5. It stops, doesn't it? That's a rational number. 1/3 is also a rational number because it what? It repeats. But is pi a rational number? No, because it does not stop. Does that make sense? I can't write pi as a fraction. There's no way. Does that make sense or no? Any number that can be written as a fraction is a rational number. Any number that can't be written as a fraction is not a rational number, and it's called irrational. Okay? All right, so irrational number is any number that cannot be written as a ratio A over B, where A and B are not integers. Also, any decimal that does not terminate or has a pattern. And the example for this one here was pi. You could also say the square root of 3, which you guys look at. If I do this, let's do this here real quick. Square root of 3. Hit clear key. Let's clear the screen out. Okay. Hit clear, and then hit the second key, the blue key, and then hit x squared right here. Everybody see x squared? And there's your square root symbol. Everybody see that? And then hit 3, and then hit enter. And notice, do any of those numbers, is there a pattern there? No.
Yeah.
So that's what kind of a number? Irrational. Does that make sense? Let's see. Does that make sense or no? Now, let's do this. Hit the second key. Okay, hit the second key. And go to square root again. The x squared key right there, okay? All right? And then put in 25, and then hit enter. Ooh. What do we know about the square root of 25? What kind of number is 25? That one's a rational number, isn't it? Correct? Because 25 is a perfect square, isn't it? 3 is not a perfect square, is it? Do you guys see the difference between square root of 3 is an irrational number and square root of 25 is a rational number? Everybody see the difference? Or no? Okay? All right. So, a real number is any of the above numbers. So a real number is every number you're going to do in this class this year. Okay? Every number. We will not do numbers that are called imaginary in here. You will do that in Algebra 2. Okay? So, this little bar, here's your irrational. These are all your irrational numbers right here. Agreed? And those numbers are pi, square root of 3, square root of 2, square root of 5, okay? And then we started out with our smallest number was natural, right? Natural right here, it's the smallest one. Then whole, agreed. Then integers, and then rational. Okay? So, a natural number has to be a whole number, doesn't it? It also has to be an integer, and it also has to be a rational number, correct? Agreed? So let's say I have 7. Is 7 a whole number? Yep. Is 7 an integer? Yep. Is 7 a rational number? Yeah, because I can write 7 as a fraction, 7 over 1, correct? 14 over 2. Does that make sense? Okay. Irrational's over here by itself, isn't it? And what kind of numbers are irrational? Non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals. Decimals that don't stop, decimals that don't repeat. Okay? So in this class, every number we deal with is going to be real, isn't it? Okay? All right. Set notation. And we'll do a bunch more examples, okay? Set notation. Here's set notation. 2 brackets. That means set notation. That means the set is. Okay? The set is. That's all that means. Set notation. Okay, now turn the page. A set is a collection of objects, such as numbers. An element of a set is an object that is in the set. Set B is a subset of set A if all the elements in B are in A. All right, here's your first example. You guys, this will be easy for you. Is a set of numbers 1 to 10. So let's let set A be all the numbers that's a 9. 1 through 10, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's set A. And the subset, which elements are both in the subset of even numbers and the subsets of multiple of 5. Okay, so here's our other subset, and they're wanting to know our subset of even numbers and the multiples of 5. Okay, so let's write all those numbers down. Okay? Okay, so it's got to be an even number and it's got to be a multiple of 5, correct? So 5 is a multiple of 5, isn't it? But is it even? No. The next multiple of 5 is 10. Is it even? So the only number that's even and a multiple of 5 is 10, correct? Yes. Is 10 a subset of that set? Yes, it is. Yes. This number here is in there, isn't it? It's just part of it, isn't it? Yes. Does everybody understand what I just said? Huh?
Yeah.
What's the matter? Okay. Even numbers. Even numbers are 2, 4, 6, 8, 10, right? But they also have to be multiples of what? 5. Correct? Is 5 an even number? No. Is 10 an even number and a multiple of 5? Yes. Today? Makes sense. A little better?
Yeah.
Okay. All right, let's do this together. Which numbers in set A, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, are elements in both the subset of odd numbers and the subset of multiples of 3? Okay, so let's let B be odd numbers. So these are the odd numbers, correct? 1, 3, 5, 7, and 9, correct? Which one of those numbers are multiples of 3? Is 1 a multiple of 3?
No.
No. Is 3 a multiple of 3?
Yeah.
Yeah, it does. What makes it a multiple of 3 is 3 go into it evenly. Does 3 go into 3 evenly? Yeah, what's 3 divided by 3? 1. 1. So 3 works, doesn't it? What's the next multiple of 3? Does 3 go into 5? Nope. Does 3 go into 7?
No.
Does 3 go into 9?
Yes.
Yeah, so your only two numbers that are both odd and multiple of 3 are 3 and 9. Does that make sense? Okay? Questions? Pretty simple so far. Have you guys done this before? Kind of? Probably set notation's probably a little different, isn't it? Correct? Okay. This one here says, in the given set of numbers, which elements are both the subset of numbers divisible by 2? So if it's divisible by 2, it has to be an even number, right? Correct? And the number's divisible by 3. So it's got to be even, and it's got to be a multiple of 3, doesn't it? Okay, so here are your even numbers. 6, 8, 10, and 12. Agreed? And which one of those is also divisible by 3? Does 3 go into 6? Yep. Does 3 go into 8 evenly? No. Does 3 go into 10 evenly? No. Does 3 go into 12?
Yes.
Yes. So those are the only two numbers that are subsets of that one there. Does that make sense?
Yes.
I have to visually circle them and do that. That's just me. That might help you. Is this making sense? Doing okay? I'm doing okay. I'm going slow enough. Huh? You all right? Okay. All right. How to order numbers. There's two ways to order numbers. Ascending, which means smallest to biggest from left to right. Okay? Ascending, smallest to biggest. Or descending, biggest to smallest. Okay? So, to order the numbers, change the number to its simplest form. Secondly, write the number in their decimal form as instructed. Ascending order means to put them from smallest to biggest, correct? Descending order means biggest to what? Smallest. And there you go. So let's do some, so after I do this, well, I give you some examples, don't I? Correct? Am I going slow enough? I mean, I get going here. I get kind of like Jimi Hendrix. I get going pretty fast on that guitar. So, okay. Jim is playing a math game where he needs to put a set of three numbers in numerical order. His cards show 40 over 11, 324 divided by 6 and square root of 10. First, put them in decimal form. Okay, so let's put 40 over 11. So pull out your calculator. Okay, everybody have your calculator. Hit clear. Get all. I like to clear everything out. And 40 over 11. That's a rational number, isn't it? Correct. How do I know it's a rational number? Because it's A divided by B, isn't it? So take 40 divided by 11, and I get a repeating decimal, don't I? Correct? So 3.63 repeating. You guys understand that bar over 6.3 means 6.3, it means it keeps going like that, correct? That little bar over top. Can't see it, my bad. Is that better? Thank you. Okay? Yes or no? Okay, now, let's do the next one, 324 divided by 36. So hit the second key, hit the blue key, and then the square, correct, right here. The blue key and hit the square right there. Everybody see that? And then hit 324 divided by 36 and it equals. Ooh, that one there reduced down nicely, didn't it? Everybody get 3 for that one? Huh? Correct? So that one's 3. Agreed? And then let's do this next one, the square root of 10. So hit the blue key, correct? The second key, and then see where it says x squared? Agreed? And then hit 10 and hit enter. And I get 3. That one there is an irrational number, isn't it? Because it doesn't. So that's going to be 3.16. I just hit dot, dot, dot because it doesn't repeat, does it? Am I doing okay? Now, write them in order, but when you write them in order, put them back in their original form. Does that make sense? So they want you to go from least to greatest. So which one was the least number? This one right here, correct? So then rewrite it back in its original form. Okay? Agreed? And then what's the next smallest one? The square root of 10, agreed? Then it's the square root of 10. And then the last one, of course, is 40 over 11. And that's what you should get right there. Does this make sense or not? Does everybody say use your graphing calculators? The reason why I'm doing some graphing calculators so scientific is, number one, you can use graphing calculators on ACT test. Plus, when you get with me in Algebra 2, I won't be spending a whole hour teaching you how to use a graphing calculator. You'll know how to use it better than me. And somebody says, how many in here have used Desmos? I love Desmos. I love it. I think it's great. Problem is, Desmos you cannot use on an ACT test. You have to use a graphing calculator. So you're going to be able to do both. When you take a standardized test, SAT, ACT, you have to use a graphing calculator. Okay? All right. All right, let's do the next one. Okay? All right, we already got 0.25, so let's clear this out. And I'll show you another little trick. Watch this real quick. Put 0.25 in and hit enter. Of course, it's just going to say 0.25, isn't it? Correct? Hit the math key. Hit the math key, and you see number 1, which says fraction. Hit number 1 and hit enter, and it puts it as a fraction as well. Does everybody see that? Does everybody get that? Did I go too fast? Hit the math key, and you see number 1, fraction. Hit 1, and then hit enter, and it puts it in a fraction for you. Isn't that cool? Now, if it's a repeating decimal, it'll write it as a fraction, correct? But if it's not a repeating decimal, you will not be able to use that function. So watch this. If I go second square root of 10, hit that, correct? That's an irrational number, isn't it? So will it write it as a fraction? No. Let's see if that's true. Hit math, fraction, enter. See, it will not do it, will it? Because it's an irrational number. Does that make sense or no? Huh? Okay. All right, so then we got square root of, so hit the second key, square root. Does everybody see where to get the square root? Hit 1 divided by 9, hit enter. So it's a repeating decimal, which is 0.33 repeating, isn't it? Correct? Then 6 divided by 25, 6 divided by 25, I get 0.24, correct? 0.24. And then I've got 0.25. least to greatest. So which one was the smallest? 0.25?
124.
0.24 is the smallest, isn't it? So and then write it in its original form. And then it's 0.25, correct? And then the last one was what? The square root of 1/9? So there it is in original form, least to biggest.